Welcome to Monday, everyone. Once again, there's a handout going around. If you haven't gotten a copy, there are copies here on the stage. Grab one. It'll save you from taking notes really fast of code that I'm going to pop up on the screen. Today, I'm going to continue to talk about arrays and loops. So give you a few more examples of how to construct arrays and how to declare them, and give you a new kind of loop called a do loop, and talk about other things related to that and how to use loops in interesting ways. So I'm going to start with automatic array construction for two-dimensional or higher dimensional arrays. Last lecture, I showed you how to build a two-dimensional array entirely by yourself, and we did Pascal's triangle. Remember that a two-dimensional array is an array of arrays, and I gave you code last week for building that up one array at a time. But a lot of the time, you just want a simple rectangular array, not something fancy like a triangle. And when what you want is a rectangular array, you can construct the whole thing in basically one line of code, and Java will construct all those little arrays for you. So for instance, suppose I want a two-dimensional array, x across and y high. Then here's the line of code that does that. It's very much like the line of code that we used to construct Pascal's triangle, but when you might recall that last week when we wanted to construct a triangle, I left the second brackets empty. And that was my way of saying, I don't know how long each row of Pascal's triangle is going to be, or they're all going to be different, so let me allocate them myself. Here, I'm asking Java to allocate them all for me, because I know how many I want, how long I want each row to be. And so what this is going to do is it's going to declare a variable table. It's going to construct automatically an array that can point to arrays of ints, and it's also going to construct x rows, x arrays, each containing y ints. And so Java will construct a large number of arrays for you all with one line of code. Again, this does several things. It constructs an array of x references. And those references can only point to arrays of ints. And then when it's done that, it fills in that array with references that are created by constructing a whole bunch of arrays of ints, x of them. And each of those arrays contains y ints. Similarly, if you want a three-dimensional array or a 10-dimensional array, whatever, and you have enough memory to store it, then you can use the same syntax with just pile on more brackets and get higher dimensional arrays. Arrays of arrays of arrays of arrays, and Java creates all the arrays at every level for you if you fill in the numbers. Now, you can't use this notation to get Pascal's triangle as a triangle. What you could do is you could just declare a rectangular array that's big enough to store Pascal's triangle and then some, and now you're wasting some memory because you've allocated more memory than you need to, but you might not care about that wasted memory. Another useful way to construct arrays, including multidimensional arrays, is through what are called initializers. And so an example of an array initializer is, I'm going to declare an array of humans call it B. And when I declare it, I'm going to immediately assign it an array, and that array gets constructed on the spot when I do this. So here I'm constructing an array on the spot. It's an array of humans, and since I stuck 3 things inside it, separated by commas, it's going to create an array of length 3 for me, and fill in those 3 human references with a reference to Amanda, a reference to Rishi, and a reference to this new human that I'm constructing right now. And you can do multidimensional arrays this way as well. So here's a 2-dimensional array of integers, and the way I construct that is by putting braces within braces like this, and then each pair of inner braces gives me a row of this array, and then the arrays are separated by commas, and all packaged up into one big array. And so just like with Pascal's triangle, this is an example where I'm not going to have a square or a rectangular array. I'm going to have C points to an array of length 4, which each of those point to something of a different length. So that's another way to get a 2-dimensional array that's not rectangular, or you can get one that is rectangular too this way, of course. Unfortunately, you can only do this in an initializer, which means you can only do it when you're declaring a variable. You cannot use this as an arbitrary way to make up arrays anytime you want. So I would love it if Java would let me assign a newly made up array to a variable that has already been declared in the past, or if I could just make up an array and pass it immediately to a function without having some sort of initializer. But for some reason, I don't know why, Java does not allow you to do this, and you will get a compile time error if you try. One more thing I want to do before I get to questions is show you that there is another way to declare arrays besides the ones we've learned. It's basically following C syntax. So for those of you who are used to programming in C, you may have noticed that I've been declaring arrays in a slightly different way than you normally do in C. The way that you declare arrays in C works just fine in Java too. And so what's the difference? Well, in Java, we usually, if you want an array of ints, you usually put the array sign, the open bracket, close bracket, right next to the int. And that's kind of the classic way of doing that in Java. And so if I declare A, B, and C this way, all 3 of those are going to be arrays of ints. Now, the C style of declaring arrays, you don't put the brackets on the type. You put the brackets on the variable. And when you do that, they apply to that variable only. So a classic way to declare arrays in C would look like this. Here I want A to be an array of ints. I want B to be just an int, not an array at all. And I want C to be a 2-dimensional array of ints. Now, that's how you would declare those different kinds of variables in C all on one line, if you wanted to. And that works in Java too. So you can do this declaration in Java. Now A is a 1-dimensional array, and C is a 2-dimensional array, and B is actually not an array, it's just an int. And finally, Java actually lets you mix the two styles, which isn't really the most transparent way of doing things, but it does work if you want to, for some reason. So here's an example where I've put brackets on int, I've put another pair of brackets on b. That makes b a two-dimensional array of ints. So now, in this example, a is a 1D array of ints, and b is a 2D array of ints. So if you see declarations like that, you will know what they mean. I usually recommend sticking to the first style at the top, but it's not a hard and fast rule. Any questions about anything I've talked about so far? Yes?
On that last method, if you put a number to indicate the size inside of the B brackets, does that allocate the size for the array or like the initial array?
So you're talking about in these last 3 lines here? So the question is, in these lines, if I put the number of items I want to allocate in brackets, like that?
Like for B, for example, because you already have B bracket and then you have B bracket, if you put a number inside the bracket next to B, what does that number indicate?
You're talking about the 3rd line?
Yeah,
Okay. So, in other words, if I did this?
yeah.
Okay. So you can't do that, actually, because Java doesn't let you put the number in the declaration, the part where you're declaring the type. So you can't have a number here. What you can do is you can have a number when you actually allocate the array. So in this example, if B is a two-dimensional array, here I'm declaring an array of 3 references to arrays of ints. But the numbers always come in the right-hand side when you do the allocation of the array in the new statement. They never come in the declaration itself. So Java is different from C in that regard. Other questions? Can you leave the first bracket empty and put a number in the second one? So, to the best of my knowledge, this doesn't mean anything in Java. This will just give you a compiler error. Can you do initializers up here? Is that what you're asking? Oh, you're talking about how to get around these compiler errors? So as long as you're declaring something new, then you can do that. So like the way to get around this, or one way to get around this, is just to say int and some throwaway name that you don't care about. And then you can do that. So this is something that you can do. This will work, because the first line is an initializer of a declaration. Your host. If you don't want to create a new variable, there isn't really a way to do that. So you need a variable to store the thing in before you can call the function on it. No, maybe not. I can't think of any way around it. Can you say that louder, please? Oh. Can you write new integer array So, Yes, you can do that, and it will compile and run, but the new integer array is not initialized, so it's just zeros. And Can you put the initializer list there? Good question. You know, the old versions of Java you couldn't, maybe the new one you can, I'm not sure. I would have to look that up. Other questions? So since we have this automatic array construction where you can construct arrays of arrays with one line, you might wonder whether the same is true for arrays of objects. And the answer is no. When you construct an array of objects, Java does not create the objects for you. And there are good reasons for that. Java doesn't necessarily know how you want to construct them, what numbers you want to pass into the constructors, etc. So you have to go through and create objects yourself. What you get when you construct an array is you get an array of nulls, which means references that don't point to anything. So here's a piece of code, which I believe is on your handout. And the first line constructs an array with room for 3 strings, but it doesn't construct any actual strings. So this first line here, what does that do? It declares a variable called sentence, and it constructs an array of 3 strings. And initially, those strings are filled in with a pointer call or a reference called null, which does not point to anything. And I like to draw X's as my way of saying null. Then I have a couple of lines of code here that do fill in some values. So we're going to set the first one to point to a string called word. Which we've just constructed. And the other one will point to an empty string. And this particular code fragment leaves the middle one null, and if you don't initialize an entry in this array, it stays null. Questions about that? Would you have to fill the empty space? Where would you say the X should be? Do you mean here? No. So that's not an array, so it doesn't store a null. It's a string. It's an empty string, which means it has 0 characters, but that's not the same as a null at all. Other question? Yeah, back there in the back. You can construct an array of type object, and that allows you to store any object in your array. But you cannot construct an array that stores different types of data, like, for instance, some ints and some floats, or some ints and some references. You can't do that. If you try to compare, did you say a string with another string, or? Oh, you can compare a null pointer with a string reference. It would be false, so it's not an error. if I now say, if sentence 1 equals sentence 2, then this compiles and runs fine, and this equal statement evaluates to false because null is not equal to a reference to another object. So it does what it's supposed to. I'm going to move on. Sorry, got lots of stuff to get through today. So the next thing I want to talk about here is the parameter of the main method, so that you know what's going on with that. When you invoke a Java program by saying Java my program, you can add command line parameters or command line switches or whatever after the name of your class that you're running. And those get transmitted by Unix through to your program in the form of an array of strings. And so when you have your declaration of the main method, and it takes as input one parameter, an array of strings, those are your command line arguments. And so by convention, people usually call that args or something like that, but you can call it whatever you want. So for instance, if I've written a little class here with a short little main method that just prints out the command line parameters. And so the idea is, here with that code, if I actually go to my Unix prompt and I write Java echo kneel and worship Java, well, what Unix does is it takes the kneel and worship Java, it divides it into different strings wherever there's a space, so a space starts a new string, and automatically produces for you this variable called args, which points to an array of length 4, because kneel and worship Java is 4 words. And it creates the strings for you. And all of this is done for you before your program even starts running. And so now this loop is just going to loop through that string and print out each one of those arguments at the command line with a carriage return after each word, like that. Any questions about that? Yes, white and gray and pink shirt. So, is there a reason why we include that even though we don't always pass in command line arguments? So, partly because you have to have some standard way of doing main that's always the same. Partly, it does always pass you something. If you don't have command line arguments, it will pass you an array of length 0, but it's still an array whose type is array of strings. So it always passes in something. If you don't want to use it, you don't have to, but it would be too complicated to have more than one signature by which Java figures out where your program starts. Mm-hmm.
How does it know therefore how does it know that new space and
So that is actually has to do with, so the question is, how does it know there's more than one word? Why does it decide to break at the spaces? And that decision is actually made by your Unix shell. And different Unix shells might make different decisions there. Or if you're not using Unix, if you're using some compiler on Windows, then usually there's some box where you type in the different parameters. And it's totally up to the shell or the compiler or whatever program puts those parameters in, how it's going to separate them. Unix, just by convention, separates them at the spaces. In the very back? Uh-huh. So generally, Unix will only look at white space characters as separators, so spaces and tabs. And I'm not 100% sure it would even do tabs as separators. But it's not any character as a separator. Most characters are not. If I put in a colon, that will be part of the string. Does that answer your question? Okay. Yes, sir. Then it still treats them as strings. So if I were to write 12, 128, 341, I still get an array of strings, and if I want to convert those strings to numbers, then I have to convert them using something like I forget the name of the method. There's a method in the integer class you can use to convert that to an int if you want it, which I talked about in an earlier lecture, and I forget the name of. Parseint, yeah. Parseint in the integer class. Thank you. So now I want to talk about loops some more, starting with the do loop. Both C and Java inherited it from C as usual, have more than one kind of while loop, and the other kind is called a do loop. It's very, very similar to a while loop. There's one big difference, which is that the loop body always executes at least once. So a do loop is something you use when you want to make sure there's always one iteration minimum of the loop. Java does not even look at the loop condition until it finishes one iteration of the loop body. So again, on your handout, you should have an example of one of these. Looks like that. And you'll notice that in order to be really clear about the fact that it always executes at least once, the loop condition goes at the end of the loop instead of at the beginning of the loop. And we still use the while keyword, it's just that the while goes at the end. So it's do some stuff while a condition is true. And it makes a lot of sense to do this in cases where the loop condition relies on something that won't even be initialized until the loop runs once. So here the loop condition depends on s. It depends on the value of s. But we don't even get s until we run the loop body and read s from the keyboard. So it makes no sense to test the loop condition before you do an iteration of the loop and actually read something from the keyboard. Then you can test whether the thing read from the keyboard was an empty string or not. And if it's an empty string, we stop. So the way to think about this is that we have a loop that does two things. You're reading something from the keyboard, and you're processing the thing that you've read. And then, if the thing that you've read is empty, you quit the loop, otherwise you go back and you read something again. And so the natural place to enter the loop is here, where we're about to read something, and the natural place to exit the loop is here after we've just processed something. So that's the simplest kind of do loop. But you'll actually notice something. Suppose that I read a line from the keyboard and it's empty. Does it really make sense to process an empty line? Not really. It kind of makes sense to just exit immediately. So you read a command. If the command is not empty, you process it. If the command is empty, you would like to quit the loop right away. So really, sometimes there are places where you'd rather exit the loop here rather than the same place you entered. And one thing that's going to help us to do that is the break statement. And there's also a very closely related statement in Java called continue that we will cover as well. So you've already seen break statements before. We use them to get out of switch statements. Well, they don't just get out of switch statements, they get out of any kind of loop. A while loop, a do loop, a for loop. You can break out of any one of these with a break statement. Question, yeah. Return is another fine way to get out of a loop. It gets out of the loop, and it gets out of the entire method you're running. So you can always do return anywhere inside a loop or a switch statement to get out of there. So what I want to do is come back to the question I was talking about a minute ago, where you have this loop that does read and process. But as I said a minute ago, the natural place to enter this loop and the natural place to exit the loop are not necessarily the same. We would like to enter the loop by doing a read from the keyboard. And if the thing we read from the keyboard is an empty string, we want to exit the loop immediately. We don't want to process something first. So the entry point and the exit point of the loop are not naturally aligned with each other. So when you want to do this, you're trying to get something called a time and a half loop. The reason it's called a time and a half loop is because you literally want to run the loop 1.5 times, or 3.5 times, or 12.5 times. You want to run the entire iteration a certain number of times, and then the final iteration, you want it to stop early. There's 2 ways presented in your lecture notes for doing that. So the handout I gave you should have 2 different snippets of code. Both snippets of code do the same thing, but in different ways. And the question is, which one is more readable? And do they have other disadvantages and advantages? So here's the first way to do it. This is a way to do a time and a half loop without a break statement. And what you'll notice about this is that I have a piece of code that's duplicated twice. So what I do here is I solve the problem by reading a line from the keyboard before the loop starts. And then I use a while loop. I have the loop condition right from the start. And if the line I read was empty, I don't iterate the loop at all. But if I do iterate the loop, then I go ahead and I process whatever I read from the keyboard, and then I read another line of text from the keyboard. And if that's empty, the loop quits. And if it's not empty, I go back and I process it. This has one disadvantage, which is the code duplication. So you know I have code here, and then I have the exact same code all over again. Why is that a problem, you might ask? Well, suppose it's not 1 line of code. Suppose it's 100 lines of code that I have to duplicate. That happens. And if it happens, that introduces new problems. I mean, it's easy to take your text editor and duplicate 100 lines of code, But suppose later you're debugging that code and you find a bug and you fix one of the 100 lines, but you forget that there's the other 100 lines where you've copied it all and you have to fix the bug there too. So if you want to make code maintenance easy, fixing your bugs, then it's not good to duplicate too much code. So typically, if you have a lot of duplicated code, you'll put it into a separate method and call that method twice so that you only have to at least duplicate one line of code. But there's another way to do it that avoids duplicated code altogether, and that's to use a break statement. So here's a time and a half loop that uses break to give you the half in the time and a half. And you'll notice that one thing that's interesting about this loop is that it starts off by saying run forever. I'm going to run this loop over and over again, and the stopping condition is never stop. But I do stop if I execute the break statement. So I read a line of text from the keyboard. I check if that line of text is empty. If it is, I break, and breaking gets me out of the loop and starts executing the code after the end of the loop body. And if the line of text isn't empty, I go ahead and process it and read another line of text. So here's two different ways to do things. And the first one I know looks shorter and easier to read, but if it were 100 lines of code we were duplicating, it would not be shorter and easier to read. And we'll see an example in a minute where break is even better. Questions about this? Mm-hmm. I think so. I don't want to swear by this, but the question is, if I declare a variable inside the loop, can I use it in the condition? Actually, the more I think about it, the more I'm not sure, because I'm wondering if I will get redeclared from scratch at the beginning of every loop iteration. So I'm really not sure. I would have to try this out and find out. I don't remember off the top of my head, sorry. Other questions? Oh, let me point out that this has a disadvantage too, which is it's just a little harder to read than the other one. This code is slightly obfuscated. It doesn't have the duplicated code problem, so that's good, but it's a little hard to read because the loop isn't aligned with its natural endpoint. So each one has an advantage and each one has a disadvantage. Which one is better? It's a matter of personal taste, really. I want to give you a more complicated example where a loop has more than one natural endpoint. So now here's an example where I'm doing the read process loop again. And I'm entering at the usual spot. I start by reading something from the keyboard. But now I have not one exit condition, but two exit conditions. I want to exit if I read an empty string from the keyboard, and I only want to loop 10 times. So after 10 iterations, I'm going to stop whether or not the user's done or not. So now I have two natural exit points. Because I'm going to exit here if I read an empty string from the keyboard. I'm going to exit here after I do the loop 10 times. When you have a loop with more than one natural endpoint, you can't really avoid using something, you can't really avoid obfuscating the loop a little bit. And probably the clearest way to do it is with a break statement. So in this loop, there are two ways out of the loop. You can break when there's an empty line of text on the keyboard, or sometimes you just naturally leave the loop when I is equal to 10. And so you just naturally come out after you've iterated 10 times. There's another way to do this, another piece of code that's also in your handout that does exactly the same thing. So again, we have two different code snippets that accomplish exactly the same thing in different ways. The second way, it shows you how you could do this without the break statement. You don't need a break statement. Instead, what you can do is you can write out a nice complicated conditional at the bottom that says, what is the condition for ending? And it includes all the reasons why you would want to end the loop. And you also have a part in the middle that just skips the process step if you read an empty line from the keyboard. Now, there are some people who would claim that this is a better way to do things because the control flow is clearer. And the reason they would say that is because the while statement gives in one place a list of all the reasons why you might exit the loop. But if you look at those two pieces of code side by side, I think it's pretty clear that the first one is more readable and easier to understand. I mean, in this case, there's no competition. So the people who prefer the second example, I think, are kind of zealots. The reason why there are some anti-break zealots like that dates back to what are called go-to statements in some languages like Fortran and BASIC and even C. There are computer languages that have a go-to statement that allow you to jump from almost any place in your program to almost any other place in your program. And these were very common in early computing languages. And of course, they're necessary in the machine code that CPUs run. But early on in the history of software engineering, it was discovered that when you give programmers go-to statements, they quickly make spaghetti code that's almost impossible to analyze and debug. And therefore, people started figuring out better ways to structure programs that don't use goto. And in fact, a Turing Award winner named Edsger Dijkstra wrote a famous article in 1968 entitled "Goto Statements Considered Harmful," which was so influential that now most modern languages don't have goto statements. Now, break and return are both limited forms of goto. But they're limited. They only let you jump to certain places that are easier to understand and analyze and give you better structured code. One other thing I want to mention is that you have to be careful with break statements because a break statement might not jump where you think it will. Because, remember, a break statement will get you out of any kind of loop or a switch statement, but it's only the innermost one that the break statement appears inside. And it will not get you out of an if statement. So, an AT&T programmer introduced a bug into telephone switching equipment where he wrote a switch statement which contained an if clause. And inside that if clause, there was a break statement. And the programmer intended that the break statement should jump to the end of the if statement. That was his intention when he wrote the code. But if break does not break out of an if statement. It breaks out of the innermost switch or loop. And so what happened was that this was all inside a switch statement, and the break that was supposed to go here really went to the outside the switch statement. As a result, on January 15th, 1990, AT&T's entire long-distance network collapsed for 11 hours. And I should mention, this code was actually written in C, but Java's semantics and syntax for this is exactly the same. So you could make exactly the same mistake in Java. Your TAs will tell you in discussion section about labeled break and continue statements, which are one way to avoid suffering this fate of working for AT&T. There is a continue statement in Java which is akin to the break statement. It's got two main differences. One is it only applies to loops. It has nothing to do with switch statements at all. And two, more importantly, it jumps to the end of the loop body, sort of like a break statement, but it stays inside the loop body. In other words, another iteration might commence if the loop condition is satisfied. And again, you should have code on your handout that illustrates this. So here's a while loop. If some condition is true, then it calls the continue statement. And what the continue statement does is it jumps to here. So it skips over all the rest of the loop body, but you're still inside the loop body. You do the loop condition test again, and if it's true, you go back to the start of the loop and iterate again. If not, you quit. I want to mention that I claimed in an earlier lecture that for loops can be automatically translated to while loops in a certain way, but that's not quite always true, because if you believe what I told you, then this for loop is equivalent to the while loop right next to it on the page. But actually there is one slight difference that comes up when you have continue statements, which is that in a for loop, the continue statement does jump to the end of the loop body, but when you reach the end of the loop body, the increment condition still executes. So these two loops here are actually not equivalent, because the for loop will do an I++ immediately after the continue statement is executed, but the while loop will not. The while loop skips right over the I++ and doesn't do it. That's the one difference between this kind of for statement and this kind of while. The last thing I want to tell you about today is constants. Java has a keyword called final that allows you to declare a value that can never be changed. If you find yourself using a numerical value that has a certain meaning, like the number 2 for February, then it's usually a good idea to turn it into a final constant. So this is considered bad style, even though it's working code. Testing whether the month is 2. Better style is somewhere near the top of your class, you declare some constants. Like, we're going to call this constant February and assign it the value of 2. And then later in the class, we replace that earlier line of code with one saying, if month equals February. Why do you do that? Because if you ever change your mind about which numerical value should represent February, if you want it to be the months numbered from 0 instead of months numbered from 1, you only have to change the number at one place in the code instead of 100 places in the code. A couple of things you should know are that for any array, let's call it X, the length field of that array is an example of a final field. You can never change the length of an array by changing its length field. You can also declare local parameters to be final. That means that once the parameter is passed in, it can never be changed. And on Wednesday, I will tell you about lists. See you later.